Today we are going to discuss solutions of KVPY 2018 question number 11. So we have been given with a function f is from -1 to 1, -1, 1 to r, and the definition is given here. So now he is asking the number of points, the set of points where f is not differentiable. So let us first of all see the function once. Here we have this component x square component, and then we have this. So we have x square which is always continuous and differentiable, and we have this component modulus of cos pi by x, let's say mod of cos t. So if you see the graph of mod of cos t, for example cos t, the graph of this looks something like this. So you have some sharp corners where this function is not differentiable. Those points are where t is odd multiple of pi by 2. For example, pi by 2, 3 pi by 2, 5 pi by 2, and so on. So this part is going to create problem at when this is odd multiple of pi by 2. So now let us analyze the different cases. Let us first check for x equal to 0, because at x equal to 0 we have change in the function, and also this function keeps on oscillating. So let us check the derivative at 0 first, and then we will come to these critical points, odd multiple of pi by 2. So let us check at x equal to 0. So we will just check the limit extending to 0, f of x minus f of 0 divided by x minus 0. So if this limit exists, then the function is differentiable at 0. So f of 0 is 0, and f of x is, we have this, so that is limit extending to 0. We have x square mod of cos pi by x minus 0 divided by x minus 0. So here you see x square and x, 1x will get cancelled. So we have x into modulus of cos pi by x. So as x approaches 0, this value will be oscillating between -1 and +1. This is a bounded quantity which is between -1 and +1, and this is going to 0. So we have 0 into some bounded quantity which is going to be 0. So the limit exists. That means the function is differentiable at 0. So now let us come to these points where t is some odd multiple of pi by 2. For example, pi by 2, 3 pi by 2, and so on. So now when t is odd multiple of pi by 2, that means x must be something like 2 upon odd integer. So we have, let's say at x equal to 2 upon 2n plus 1, something like this. So let us find, let us see whether the limit exists here, f of x minus f of this upon x minus this. So limit extending to 2 upon 2n plus 1, f of x minus f of 2 upon 2n plus 1 divided by x minus 2 upon 2n plus 1. So now you see this quantity is going to be 0, because when x is 2 upon odd multiple, 2 upon odd integer, this is basically going to 0. So this value is 0. So what we have is, we have something like this, limit extending to 2 upon 2n plus 1. We have x square into mod of cos pi by x upon x minus 2 upon 2n plus 1. So now we need to evaluate this limit. If this limit exists, then the function is differentiable at these points. If the limit does not exist, then it is not differentiable at those points. So let us slightly manipulate this. Let us write it as sine of pi by 2 upon 2n plus 1 minus pi by x divided by x minus 2 upon 2n plus 1 limit x tending to 2 upon 2n plus 1. So now you see, if you take here pi by 2, suppose I am just slightly converting it into standard form. It is like sine h upon h. It can be converted into that form. And we can clearly see the limit of this does not exist. For example, here this is in the form of, let us say, h. So if we try to convert this, so we'll just write it slightly like this. We'll just write 1 by pi. So x into 2 by 2n plus 1 divided by pi into pi divided by 2 by 2n plus 1 minus pi by x. Okay. So I am just slightly modifying the denominator. Now you see, this is anyway x will get cancelled. You have x upon something. This limit exists. Now you see the second part of the limit, modulus of sine h upon h, where h is tending to 0. So we know mod of sine h upon h does not exist. When you take plus, if you take 2 by 2n plus 1 plus side, you will get plus 1. So basically plus 1 and minus 1. So this limit does not exist. So ultimately the whole limit does not exist. Limit does not exist. That means the function is not differentiable at all these points, at all the points where x is 2 by 2n plus 1. Points like 2 by 3, 2 by 5, 2 by minus 3, 2 by minus 7 and so on, which comes between minus 1 and 1. Okay, that's it.